Yeah, dear students, I welcome you all for the online learning platform for the course Warehousing Automation. So, through video lectures, we are learning the course for the sake of honors degree. And now, this particular presentation will take us to the fourth chapter of Unit 5. So, Unit 5 basically discusses about advanced technologies and future trends. And this presentation will take us to two important advanced technologies which can be or which will be a part of the warehouse in the near future. So the topic of discussion is going to be drones and AMR, autonomous mobile robot. So first we'll discuss what is a robot, or maybe first we'll go ahead with what is a drone, then we'll discuss about the robot part. So drone, so nowadays you would have seen drone in many of the basic commercial applications, like for the case of photography or for the case of maybe during this operation Sindoor, you would have seen for the sake of attack. So now we'll discuss what is a drone, then we'll see its application with respect to the warehouse applications or warehousing automation. So basically a drone is an UAV, that is unmanned aerial vehicle. Okay, so they are unmanned aircraft, so they are also a part of an aircraft, but we don't have humans or any other regard. So it is going to be an unmanned aircraft or unmanned aerial vehicles, in short called as UAV. So these robots has the capacity to fly. So they will be, the position is or the design is in such a way that they are very small and delicate, and they have the ability to fly, and that can be remotely controlled or fly autonomously using software controlled flight plans in its embedded system, which work in conjunction with onboard sensors and a GPS system. So basically robot is a a drone is going to be an UAE, that is unmanned aerial vehicle. So we are going to have a controller in order to execute control or exercise control over the UAV. As well, it is going to have onboard battery power, it is going to have sensors on board, and it is going to have a GPS system, global positioning system, that is the way how it moves, which area it moves, and of course everything is controlled in a remote manner. And there are some applications, some higher end drones, where even they have the potential to fly automatically. They can, that is autonomously they can go ahead even in the absence of control. But however, manual control will not be there, but software control do exist in the process. Okay, so this is what basically a drone is all about. So drones are flying robots that operate in three-dimensional space within warehouses to scan, tag and track inventory. So this UAE, this UAV, which is going to fly in a regular space, when it is brought into the application of a warehouse, so how it is going to do is, so they are considered to be flying in a three-dimensional space. So we have got three dimensions, right? So X, Y and Z. So within this three-dimensional space, it is going to fly in particular route, so that it is not going to get disturbed by any of the parts of the or any of the accessories of the warehouse. So that is how the system is going to all about. So what all are the tasks it is going to done? Maybe it can be used for scanning, it can be used for tagging applications and tracking inventory. We'll see how the circuit is going to be, everything in the upcoming slides. So here there is this particular image which shows the presence of that is drones as well as AMRs, autonomous mobile robots. So finally we'll see what is a comparison, differentiation between both these elements. So applications in warehouse. So what sort of application does a robot, that is flying robot or drone, is going to suit? So first, the basic application is going to be automated inventory audits by scanning barcodes and RFID tags. So manually how it is to be done and how it is going to work, we'll see in the upcoming slides. Second is going to be real-time mapping of warehouse layouts and capacity calculations. So how much the warehouse is loaded, all such things can be calculated from an aerial, that is bird's view perception. We can calculate all such things. Item tracking and searching by updating warehouse management systems with exact item locations. So the part, maybe if it is a very large warehouse, what happens is the part will be anywhere, somewhere on the transit or somewhere it will be available. Maybe it would have been picked, but it would have not come for packing. So in the due course where the product went, when you wanted to track it, trace the item, then drones are going to be an fantastic alternative in this regard. Applications in warehouse. The second continuation is going to be video surveillance for improved security with flexible flight patterns, remote manipulations for accessing difficult and dangerous places such as ice shelves or dark areas. See, we know the foremost consideration when we go for any of the utilization of a warehouse, we think in the volumetric cases. So we go with volumetric calculations rather than area. So volumetric case, when we go, what is the problem is some cases the height of the racks will be very high. So even when we did risk assessment, what happened is we experienced that the risks are high when they go for then higher elevated surfaces. So how to bring down this particular risk means by employing drones. Why? Because the drones have the flying ability, so they can go for such a difficult areas with ease. We'll be able to access them. So how drone basically works is, first it has got an autonomous navigation. So warehouse drones use onboard sensors and AI to navigate complex indoor environment, often without GPS, to follow pre-programmed paths. See, we know that there is an aisle configuration. We have got racks in between, and the gap in between the two successive racks is called as aisle. So when we have an aisle configuration in this regard, the drone is supposed to travel only in that aisle. So in the available space only it is supposed to travel. So under those scenario, what happens is the drones have autonomous navigation sensors. Thanks to the sensors on board available, so they are able to sense the hindrances in their trajectory, in their flying path, and therefore they are very careful enough in traveling. Then data collection. They are equipped with cameras, scanners and readers to collect data on stock locations, item IDs and product conditions. I want you students to recall about the concept what we discussed in the unit 1 AIDC, automatic identification of data and its capture. Clear? AIDC. So there are going to be some labels, RFIDs, RFID tags, or maybe barcode scanners or QR code. Likewise, things are going to be there for the case of tracking, and drones can be employed to track such things. Rather than manually we go and we experience risk, drones can be used with ease. We'll be able to use. Data integration. So whatever the data we get, so obviously that data has to be processed. So therefore what we do is we just go ahead with integrating with the ERP or WMS, and we can get the real-time updates. So there are 10 products in the rack and one product has been taken, means immediately the drone will go and capture the status and it will automatically update. So out of 10, one product has been taken away. So therefore right now only 9 products are available. So that data will automatically be updated into the WMS platform. Automation. So once their mission is completed, drones typically return to charging stations to upload data and recharge, requiring minimal human intervention for the data collection process itself. See, first thing what we need to understand is drones don't have the potential to generate power automatically. That is, they have got onboard battery, and this battery is subjected to draining. Upon usage, yes, the battery is going to lose power. So what obviously happens is that drained battery should be often or frequently based on the discharge rate, based on the application rate, it has to be charged. So drones can be automatically made, or program can be made in such a way that it can directly go to the charging station and it can get charged. So once it is charged, obviously it can be retrieved for the case of application. So this is how what exactly the manual activity does. That is, when we have got racks, so somebody is going to be there to monitor, or some sort of input is going to be given, and the worker is going to go along with their data capturing device, say any sort of scanner. See, scanner means independently the scanner will not be in a position to work. Obviously there should be a system, that is a laptop or a desktop should be there, so that whatever the data captured by the scanner has to be stored into the database of the system what we use in a local case. So such things will obviously be connected to the cloud, and therefore it can be taken for the upgradation in the WMS. But still what happens is manually it is done. So when the activity is being done, the problem is we are going to face risk. See in this image, the worker, what she does is, so she is holding the data capturing device, that is the laptop, as well as the data storage device. Both the things she need to go ahead, and as well she need to focus on the safety also. So obviously see the way how she stands. So this is what the risk assessment what we face in the traditional process. So when there is, see, at the end of the day, obviously the data has to be updated. what was the starting inventory and what was the ending inventory on that particular day. That has to be updated. So obviously when manually when we do, so we are going to face such risks. Okay, so what happens if she falls down? So not only she is going to see resources are going to get spoiled. So keep away reserves. What happens when she falls on the successive ladder or on the successive rack? So think of trauma. So that is the sort of risk, and how drones are going to replace this like this. So drones can be operated from a safer distance. So the controller can be kept manually and drones can be operated wherever you want. You can go ahead. But the only thing what we need to be very cautious is there are no hindrances in the flight path of the drone. So that is the only path, or that is the only thing what critically we should consider. So now this is how it works for the case of manual updating. So now we discussed about the manual case. So manually he or she, the employee, will be going to the corresponding rack and they do all sorts of inventory monitoring. But now when we go ahead with a drone, this is how it is going to be done. So the first step is control the drone, go to that particular position, get a capture. So that particular path is going to have an identification mechanism, even that is also being captured. Now whatever the image has been captured by the drone, it is going to be taken to the cloud. That is, the image is going to be uploaded to the cloud, and therefore the processing is going to occur into the cloud. That is, what sort of number is it, what was the product. So based on that ID, it is going to be updated into the cloud, and therefore any of the smart devices what we have in the floor across whatever the geographical location we are, so the same data is going to be updated. So therefore manually whatever the task was done has been comfortably with ease, with not major amount of investment we are able to do. So that is the biggest advantage as far as drone is concerned. So as we discussed, the same thing in case of step by step. So first drone is going to collect the data, then it is going to send it to the warehouse management. So there the process is going to analyzed in such a way that the item is going to be identified and it is going to be updated, and finally the record will be reflecting into the database. So that is the thing what we learn. Now what are the technical features here is the computer vision for label barcode recognition. Yes, that is possible. It is going to be done with ease, without any sort of difficulty. Only thing is there should be a person to take to that particular level. There are some height, say 10 feet of height product is there, means that drone has to be taken to that level, so which is of completely risk free. Then second thing is obstacle avoidance using sensors and algorithms. So there are several sensors or there, deep learning items are there. So therefore such algorithms can be easily used here for the case of obstacle avoidance. Integration with cloud AI for instant data analysis. So this is going to be another beauty. So we can just integrate to the cloud base, and therefore whatever the data being captured by the drone can immediately be sent to the software. Then autonomous navigation and fleet management. So even multi drones also possible. See, nowadays even for cultural cases or to maybe with respect to some events, so there are some drone flying clubs or there are licensed pilots or there who can handle a swarm of drones. So fleet of robots can be possible. So it is possible without any sort of collision also it is possible. So these all are the advantages of using drones in the warehouse case. So the elements present in them are, so drones are going to have these following elements. The first is obstacle sensing systems. The next is going to be onboard processing power. In short, so that is the one which manages power. Then smart interface. Yes, we can develop the interface as we wanted. Camera system. So the very essential thing is it can have a camera and it can capture the image and send to us. So cloud drive, the same can be integrated to the cloud for the sake of accession of the data. And finally data analytics. So one single element is going to take care of these many activities. So that is the advantage what we need to think. Now what are the benefits? So the first benefits is it is going to speed up inventory management, reduces physical strain and errors. So improves accuracy and helps optimize storage space, reduce costs and manual workload, supports safer workplace. So risk is absolutely brought down, and therefore it is going to be worker is going to experience a safest workplace. So now whenever there is a technology, when there are some benefits are there, obviously there will be limitations also will be there. So the limitations here are indoor navigation complexity. So when we have got very tight congested layout, what happens is maybe operating a robot in such congested area might be very difficult when you have got, especially when we have got a narrow aisle rather than a broad or in the context. So therefore flying of such in that particular scenario might be a difficult task. Reliability, stability and scalability and affordability of drone system. See, only one drone is used, no major deal. But when you have got a fleet of drone, so that has to be thought of. Why? Because so usually there will be one particular fan being rotating onto the any of the warehouses. So it is called as a very large small volume fans. So where can you see in our college MPH you would have seen there are some big fans are there mounted onto the roof. So they are going to rotate in a very slow case, but we are going to get good amount of air. So such fans are called as very large small volume fans. So what happens is when you have got a fleet of drones under such scenarios, so we need to be very careful. So what happens else, it is going to damage, that is either the resources, either the drone or the fan, which or some cases even both. Okay, the chances of damage is high, so that has to be taken care in a very crucial condition. And integration challenges with the existing warehouse management. So we need to work a lot in this regard, how to update the data. So the authenticity has to be carried out. So some sort of approval and software processing is essential. So these all are the limitations and considerations. So I just wanted you students to recall. See, earlier we discussed about SWOT analysis. So whichever is identified under the category of threat, obviously it has to be an opportunity. Whichever the thing we find as weakness, obviously it has to be converted into weakness with respect to time. So please have a keen observation in this regard. So the next, autonomous mobile robots. So the first was with respect to drone and now is with respect to AMR, autonomous mobile robots. See, now you can see there are two images over there. So the right side, the person is having a manual forklifter, a manual trolley. Okay, so manually is going to pull, and the second case is going to be AMR. So now consider both these cases. Which one is going to be quite easy, AMR or a manual case? See, why manual case is not preferred is the first case is they are not going to be consistent with respect to time. See, at the starting of the shift, they will be highly energetic, they will be able to work in a very prompt way, but with respect to passing of time, so obviously their efficiency is going to dip. So that is a visual fact. Okay, why? Because he is a human, so he is subjected to fatigue. With respect to time, definitely they will be experiencing fatigue. And if you have got some extra workload, if you ask them to do, some cases their health may not be permitting or they will be completely tired. So under those cases, we wanted to have an alternative. So that is going to be AMR. So AMR is not going to say you anything. Only thing is it should have sufficient power. So once if it is charged enough, then it is going to obviously do the task in a very extraordinary way. So AMR warehouse robots are advanced robots designed to navigate and perform tasks within intra-bound logistics, within logistics warehouse environment without human intervention. See, one thing you recall, we just discussed about intra-bound logistics, that is within the warehouse only it is going to work. It is not going to work outside the warehouse, only within the warehouse it is going to work. So equipped with sophisticated sensors, cameras and navigation systems, AMRs can map their surroundings, detect obstacles and determine the most efficient path to complete their task. See, AMR is one particular thing which you need not to specify the path. Why? Because you just tell like a Google map. Like a Google map, what we do, from where am I now and to which point you intend to go, you just give it, it will show you multiple path. Okay, it will show you multiple paths. So this is going to be greener, this is going to be shorter, and here traffic is going to be heavy likewise. And it is left to the user to select the path in which you wish to travel. So you just select the path. Likewise, here you just give the instruction. So they have got web processing software within them and they will identify the track. So once the path is identified, there will be definitely obstacles will be there thanks to the lidar sensor. So that sensor will take care. So automatically it selects its own path for the case of smooth travel. So in warehouse logistics, AMRs are primarily used for transporting goods, managing inventory and assisting order picking. See, earlier case, drones were used for majority of the cases, but we don't use for the case of order picking. But here, the main purpose is only order picking. So their ability to operate autonomously allows them to perform these tasks with high precision and reliability, significantly enhancing overall efficiency in GTP, PTP and 3PL. So we have already learned this GTP, goods to person. So I am somewhere standing in a counter means from that particular lag that product should come to me. So GTP. So goods to person. Then second PTP, person to person. So I am a picking guy. From my end, the product should go to the packing guy. So from a PTP case, so automatically it goes there. And third party logistics. So from an outside, somebody brought the product and kept into the unloading area. From the unloading area to the storage space, that has to be taken care. So within an intra-bound logistics application, so AMRs work the best. Integration of AMR warehouse automation ensures improves workflows and optimize resource allocation. So these all are the charging stations. So once the charge is low, obviously what happened is only things we need to assign space for them. So it comes exactly there. It comes for charging. So it has got all sorts of denotion, warning mechanisms available in this. So everything is taken care. So manual intervention is not essential unless and otherwise some sort of maintenance or failure comes into the system. They are very capable enough to take care of them. The key functions. So what all are the activity they do is, the first thing is material transport. So as we discussed earlier, material transport, usually they move the pallets, bins and boxes between zones. Order picking. So human will be keeping it on one particular platform. So rather than manually pulling it up, so it is going to take care, where you don't have any sort of conveyor systems, AMRs will take care. Inventory management, automated stock counting using onboard scanners. So same thing like earlier case, RFID scanning everything, but not on the high level elevated surface. In the basic low level surfaces it is possible. And sorting and routing. So here we don't worry about the route at all. We don't give the route at all. Only thing is we give the from and the destination point. So rest, the AMR is highly efficient to carry out the task. So handling returns. So similarly for the case of restock, everything. So it is going to help us in moving from one point to another point within the warehouse. So that is a constraint. Technical features. So dynamic route planning based on real-time warehouse layout, obstacle avoidance using LiDAR scanner, vision and AI, integration with warehouse management systems for workflow automation. Now what are the benefits we will see? The first benefit is flexibility. Yes, since we are not giving any path, so obviously it is going to choose the path. So therefore it is highly capable for the case of flexibility. The second thing is safety. Yes, safety is there. So safety means it is not going to pose threat for any of the resources present inside the warehouse. So safety is ensured. So they are CE certified. CE means confirmation to European standards. So therefore it is highly safe for the workers to work because it is not going to collide at any point of time. Then labor. So it is going to minimize the efforts of the labor, that is exertion of forces by the labor is minimized drastically. Then streamlined implementation. See, it is very commissioning and everything is very easy. Unlike other cases, no alignment, nothing. Just come, install and give the points, requisite points, just save them everything into the database. It becomes very easy for installation and implementation. Trusted technology and service support. So it is very simple. So the construction is literally simple. Okay, the construction is literally simple. So therefore we can go ahead with service in the minimum efforts. So built for the future. So mainly it is for the future cases. Okay, future majority of the cases, even right now DHL or Amazon, they have already switched to AMR. So today many of the bigger, higher level companies, large scale companies, they are migrating themselves to AMRs. So now the basic comparison between drones versus autonomous robots with respect to some features. The first thing is the tasks. So drone is used for inventory scanning, surveillance and tracking. But autonomous robots, mobile robots, AMRs are used for material transport, picking, inventory management. Mobility. So Drones have the ability to fly, hover, so it will stand still in one particular area, okay, hover. So basically they work on three-dimensional space, but here it is no only ground, it is going to have a physical contact, it is going to move, therefore only area based. So it is volumetric, this is area based. Typical payload, so drones, they don't lift weights. Basically the design of the robots, that is the drones, are very light, compact, and cameras and scanners only, that's the maximum thing what it can hold. But AMRs are not so, so they are very good enough for the case of pulling. So the load lifting capacity starts right from say some 100 to 200 kgs, the starting. The basic AMRs have the tendency, and even it goes up to tonnage, up to 1.5 or 2 tons of tonnage weight payload it can go ahead with. Navigation, it has got SLAM, GPS, indoor mapping vision, and autonomous robot, mobile robots, AMRs, basically they have got LiDAR. So LiDAR is the main sensor, and here is SLAM is the main sensor. Data integration, yes, both can be integrated. The key benefits is for the case of drone, so reaching high shell for risk areas is going to be very easy, and here it is for the case of heavy weight applications, pulling them is going to be very easy. So challenges is, so indoor we have got a good amount of hindrances, so within which it is supposed to go ahead with. And here layout adaptation, what does this mean? Layout adaptation is, see, it has got a turning radius, so you wanted to make a U-turn. So probably you would have experienced in some of the manual buses, see, when our college buses come towards the college right from in the morning, so in front of the toll plaza they used to go ahead with a U-turn. So if the roads are absolutely free, no issues. But if because of the foot cart and something there is some sort of congestion, the bus will not be able to make out a U-turn. So what the driver does is, after taking majority of the curve, he comes back little bit and then he just tries to maneuver to take it to the path. So likewise, whenever we go for aisle configuration, we are supposed to provide a precise turning radius, and plus some sort of clearance has to be given. So such adaptations has to be taken care when we go ahead with the designing of the layouts. So finally, now we are in the end of the presentation. So summary. So today's discussion took us to three important aspects. The first aspect was working of drone, especially in the warehouse context, then working of AMR in the application of warehouse, and finally comparison between these two. So with this, we come to the end of the presentation. So dear students, any doubts, kindly note it down. We shall discuss the same during our online or offline classes. Okay. Thank you for your active participation.